Before 1887, treating a hernia was an exercise in frustration. When a patient arrived with a rupture in their abdominal wall, surgeons would simply shove the protruding tissue back inside and sew the skin shut. Predictably, the gap remained, the pressure built up, and the bodily wall kept tearing open. That cycle finally broke when Italian surgeon Eduardo Bassini stepped into operating rooms like this one in 1887. He realized that to stop the recurrences, you had to physically reconstruct the damaged anatomy. Bassini went deep into the groin, isolated the weakened edges, specifically the conjoined tendon and the thick band of the inguinal ligament, and manually pulled them tightly together with sutures to close the hole. Recurrence rates plummeted, but because these distinct muscle groups weren't naturally meant to touch, pulling them across a void put constant stress on the stitches. Over time, those tense sutures could slowly slice right through the living muscle, much like a wire cutting through cheese. Bassini mapped the anatomy perfectly, but his method introduced a new mechanical hurdle for surgeons to overcome: physical tension. To solve that tension, doctors initially tried to overpower it. An American surgeon named Halsted decided that if one layer of stitches pulled through, he would stack multiple layers of tissue on top of each other through sheer brute force. Forcing multiple layers together only amplified the strain. To make his complex repair fit, Halsted even had to displace the patient's spermatic cord to sit directly under the skin, causing severe testicular complications and chronic discomfort. By 1945, surgeons tried a more delicate approach. The Shouldice Clinic in Canada moved away from brute force, focusing instead on overlapping a deeper, thinner layer of tissue called the transversalis fascia. This achieved the lowest recurrence rates of any tissue repair, but the overlapping four-layer technique was incredibly complex. Its success relied heavily on the individual mastery of the surgeon performing it. Other surgeons, like McVay, tried to broaden the repair to cover adjacent weak spots, like the femoral space. To relieve the intense lateral pulling that resulted, surgeons literally had to make secondary incisions in nearby muscle just to allow the main tissues to reach each other. A clear pattern had finally emerged for surgeons. No matter how brilliantly human tissues are stitched together, pulling them across an empty space guarantees high stress and eventual failure. Fixing the geometry wasn't enough, the mechanics needed an overhaul. If surgeons couldn't drag native tissues together, the only logical step was to fill the void with something else. This animation illustrates the idea proposed by French surgeon René Stappa. He placed a massive synthetic mesh directly in the preperitoneal space, right behind the abdominal wall. Instead of pulling the torn edges tight, the mesh acted as a wide, reinforcing backstop, entirely eliminating tension. The problem was how you got it in there. To reach that deep pocket, Stappa's procedure required splitting the patient's abdomen down the middle, creating a massive, brutal incision. In 1984, the Liechtenstein repair simplified things by laying a flat piece of mesh on the outside of the muscle wall. It was much easier to learn and quickly became the global standard. But the stitches used to nail the flat mesh in place frequently trapped nerves, causing chronic groin pain. Some doctors tried a shortcut, literally jamming a tight mesh plug directly into the hernia hole. Those solid plugs often migrated out of place or dangerously eroded into adjacent organs. Synthetic mesh had successfully defeated tension. But surgeons were now battling a new enemy, the traumatic bodily access required to deliver that material safely. The goal shifted toward navigating the human core without inflicting major collateral damage. TAPP was the first minimally invasive solution. Surgeons routed long instruments straight through the abdominal cavity to patch the hernia from inside. But entering this space puts instruments dangerously close to the bowels, risking organ injury or internal scar tissue. To avoid the digestive tract entirely, surgeons developed the TAPP repair. This technique tunnels a narrow path directly between the muscle layers, delivering the mesh while staying completely outside the main abdominal space. TAPP removed the risk to the organs, but tunneling between thick muscle layers creates an impossibly cramped, claustrophobic workspace that pushes human hands to their absolute ergonomic limits. To operate inside a pocket of tissue barely large enough to hold a few instruments, medicine turned to advanced technology. Robotic surgical systems provide high-definition 3D vision and fully wristed instruments that bend like human joints. This allows a surgeon to fluidly stitch and dissect inside that tiny, ideal plane between the muscles. But this setup comes with a catch. The robots introduce exorbitant healthcare costs and significantly longer operating times. And despite the massive price tag, they don't inherently improve recurrence rates over standard laparoscopy. When you look back at the timeline, a clear chain reaction emerges. Bassini's anatomical fix caused the tension that led to Stappa's mesh. Stappa's giant incisions drove the push for minimally invasive laparoscopy. And the extreme difficulty of that laparoscopy is exactly what put billion-dollar robots into modern operating rooms. The flawless surgical procedure doesn't exist yet. Medical history is an endless, necessary relay race where solving one complication inevitably engineers the next, driving human healing forever forward.